This is significant because we've been working on this for 15 years, trying to achieve the boot up of the first synthetic chromosome. So we had to first solve all the chemistry problems to make large DNA molecules. We reported the first synthetic chromosome about 2 years ago. It was about half the size of the current one we've made, but we couldn't get that booted up. The cells grow way too slowly. We think we will eventually. So this is actually the first time ever we've had a synthetic cell from a synthetic chromosome. So the chromosome was assembled starting with 4 bottles of chemicals assembled in yeast, transplanted from yeast to a recipient bacterial cell, and then that bacterial cell transformed into a whole new cell based on what was in the synthetic genome. So it's a whole new paradigm for how to do things in science. We've been aiming in this direction for a long time. Now that it's actually happened, it's a different situation than struggling to try and get there. We've been predicting for 3 years we would be there. We had to overcome a lot of biological problems, which solving those is important for understanding this whole process. So we started even back in 1995, even asking for ethical review before we did the first experiments. And that's been an ongoing aspect of this work. So asking the ethical questions, driving the ethical discussion has happened in parallel to all this new science that's been created. I think this is a critical first step for the field of synthetic biology to really start with information in the computer, write new software, get that software booted up to create new biological systems that can change how we proceed. We're trying to use that. We're making fuel out of carbon dioxide with the energy coming from the sun. We're trying to make new vaccines, but I think it's going to be hard to envision an area of life that's not impacted by this technology.